Hi, today we're going to show you how piezoelectric transducer works. But before that, we're going to show you how it works in theory. Piezo came from the Greek word which means press, and it's connected to the word electric because when we induce pressure on it, it converts mechanical energy to electrical energy. That's why it's called piezoelectric transducer. When the silicon crystals are not stressed, both positive and negative ions are aligned, for which the total charge is equal to zero. But when we either induce pressure or tension on it for a short period of time, more positive ions, which are silicon atoms, move and concentrate on one side, and negative ions, which are oxygen atoms, concentrate on the other, producing small amount of voltage, which is actually enough to power an LED.
An example is this. What I have here is a contact pickup that has a piezo transducer like this one. It is used on acoustic guitars and classical guitars and also a violin. But first we're going to test it using a oscilloscope. We are going to connect this transducer to a oscilloscope. So what we're going to do is we're going to apply high pressure into the element, and let's see what happens. As you can see, the resulting waveform fluctuates as we hit the element. So now we're going to test an original solid object as a guitar.
And now we're going to demonstrate to you an actual application of this transducer. So what we do here in our setup is to connect the transducer to an amplifier that we set up here on the breadboard, and then connect it to the speakers to hear the audio sound that it produces, and also the oscilloscope to see the waveform. And to test it, this is the sound of the guitar being tapped, and that's the waveform there. This is the sound of the guitar itself, strings being strummed. And now we're going to test it with the speakers on, and it's on. So as you can see, the sound of this guitar as we tap it is amplified, including the sound of the strings. As you can hear it, it's being amplified. When we try to remove this, you can actually connect it or paste it or a while ago we demonstrated to you how this transducer converts mechanical energy to electrical. But now we're going to demonstrate to you that this transducer also converts electrical energy to mechanical, like a speaker. And based on our setup here, we connected the output of our homemade oscillator, which produces sine wave, as you can see, to the input of our amplifier. And the output of this amplifier is connected to the transducer itself. So I will show you a closer. So now I will move the mic closer to the transducer for you to hear it. So here we go. And I will change the frequency so you will hear different pitches of sound. And I believe that's it.